Howdy. Welcome to the last video for Chapter 1. This is Section 1.7 of Solving Absolute Value Equations and Inequalities. So we're going to discuss what an absolute value is. And that's actually the first question in the Google form. So absolute value can be defined a few ways. One way you could define it is the distance between 0 and the number you are working with on the number line. And more specifically, it's going to be the positive distance. So for example, perhaps if I have 6, here's 0, here's 6. What's the distance between the two numbers? The 6. Or you can think of it as a difference also, but it's a positive difference. So that's just 6. So the output is always positive. That's another way you could define that as well. One that provides always a positive output. Or it could be 0, because the absolute value 0 is 0. So for B, if you work out what's inside, and by the way, you follow PEMDAS. So absolute value is the same as parentheses. So you still get 6 because negative 6 is over here, and it's also 6 away from 0. Now for part C, there are two answers. You can get negative 10 or 10. Because again, if you draw a number line, here's 0, here's 10, here's negative 10. Both of those numbers have a positive distance of 10 from 0. So usually you're going to see two answers when you're solving an absolute value equation. And that's actually going to be kind of one of the other questions in the video, but we'll delve deeper into that later in this video. So here, y minus 7 is 10 away from 0, just how x was 10 away from 0 when we were looking at part C. And of course, x is negative 10 or 10. But here, y minus 7 is also 10 away. So that means that y minus 7 definitely is going to equal 10, but it could also equal negative 10, right? Let me make that a little more clear. That's really messy handwriting. And just, I cross my 7s just so I can not confuse them with 1s. So y equals 17 or negative 3. And by the way, I know I have 0 on the number line, but really I'm looking for numbers that are 10 away from 7. That's really what's happening. When you have absolute y minus 7 equals 10, what it really means is find two numbers that are 10 units from 7. So that's why you're getting two answers. Because clear 17 is 10 units from 7, and negative 3 is also 10 units from 7. So we don't focus on 0 in this case because we introduced the minus 7, which caused a shift in the in the equation. So we'll talk about shifts and all that stuff when we get to chapter 2 and how that looks graphically. So really, all we're doing is we're setting the expression inside the absolute value equal to the number that we see on the right side, and also equal to this negative counterpart because we can go the other direction. So once you kind of see the pattern, you don't really have to think too hard about it. 5x minus 10 equals 45, or 5x minus 10 equals negative 45. A little bit hard to express that with a number line. So we'll just kind of sort of just follow the pattern we saw in part D, because it works. 5x equals 55, 5x equals negative 35, x equals 11, x equals -7. And those would be the two values that would satisfy that absolute value equation. So the step-by-step process, when you're actually solving that absolute equation, we're going to do in number 2. C could either be 0 or positive. So what you first want to do is separate into two equations. One equals C, and the other equals -C. And you just solve each equation separately. And then I strongly suggest you check your work, because you are going to run into some cases where maybe the answer you found in step 2 actually doesn't satisfy the original absolute value equation. So you're going to plug back into the original absolute value equation. So I'll do this in red. So we're going to separate into two equations. Ax plus b equals c. Ax plus b equals -c. You solve each. So ax equals c minus b. X is c minus b over a. Ax equals -c minus b. X equals -c minus b over a. I'm not going to check right now. Do this when you know what a, b, and c are as numbers. A little bit tricky to do that with the variable expressions there, but you should always check your work. Now, for 3, a great question. Why be a waste of time? That's because, and this is actually going to help with the Google form question, even though I'm going to discuss it again in example 4. But that's because, and this will help for the Google form, I think, question 3. Absolute value expressions are never negative. They're always positive. So if you were to have something like 2x plus 1 equals like -5, that's impossible. That can't work. How can you make that? It's either 0 or positive, right? It can't be negative. So don't waste your time trying to solve if the equation, or sorry, the absolute expression equals a negative number. Yeah, you'll be able to get some answers, but it's not going to satisfy when you check your work afterwards. It's not going to satisfy the equation. So let's look at these two here. So 2x minus 9 equals 15. 2x minus 9 equals negative. 2x equals 24. X equals 12. 2x equals -6. X equals -3. When you check your work, absolute value of 2 times 12 is 9 equals 15. That's going to be 24 minus 9 equals 15. 15 equals 15. Absolute value of 15 equals 15. 15 equals 15. Check. So do absolute value of 2 times -3 minus 9 equals 15. Absolute value of -15 equals 15, because you can get negative. Actually, let me backtrack a tad. I'll skip steps. That becomes absolute -15 equals 15. 15 equals 15. Check again. Now, this is going to help answer the Google form question. What if you started with this? The problem, and you don't have to write this down, you can just watch, is that sure, 2x minus 9 equals -15, and 2x minus 9 equals +15. We're still going to run into the same answers that we did before, but the problem is that when you check your work, you plug -3 into here, we know that the output's going to be positive because that's the whole point of absolute value. Likewise, 12, it's not going to equal the other side. So um, if absolute value equals a negative number, again, it can't work because absolute value are never negative, right? And so it has to be positive or 0. Now go and try part B on your own. I'm going to at least set up for you guys. So 4x plus 6x, 4x plus 10 equals -6x. Okay, go and pause the video, try it, and we'll see what you get. Okay, hopefully you pause the video. So that's easy, 5. That's easy, that's -1. However, I know that this is not going to work, and that's going to work. Why? The reason why is that if you plug 5 in, you're going to have 20 plus 10 equals 30. Boom, 30 equals 30. That's fantastic. When you do for the other one, plug -1 into plug into the original absolute value equation, get 6 equals -6, which is not true. The reason why this happens, and we'll have this discussion when we get to chapter 2 in more detail, is that if you were to graph an absolute value, which kind of looks, I don't know, kind of looks like that, and if you graph a line, maybe your line kind of looks, I'll do a different color, kind of like this. We see here that the probably going to, actually, let me draw one that's a little more accurate to 6x. It's kind of like that. We see that they're going to touch once there, but they probably don't touch ever again. And this is the connection that we're going to start making often with graphical solutions and algebraic solutions. Clearly, we're doing things algebraically right now. We'll do things graphically when we get to chapter 2 and then start talking about connections. Is that the points of intersection have to be equivalent to the number of solutions you get. So if you get one solution, you have 1 point of intersection. If you get 2 solutions, you get 2 points of intersection. That's why for some of these absolute problems we're doing, we're getting 2 answers, like in number 4, part A. If you graph an absolute value in a horizontal line, you get 2 possibilities. And so we see that there's a confirmation between the graphical and algebraic solutions. We're going to talk more about that when we get to chapter 2. That's going to be kind of the theme for the school year, is how do we connect algebraic and graphical solutions, because that deepens our understanding of this stuff. Otherwise, we'll get stuck memorizing and then we never really retain stuff. So we want to get that deeper understanding. So we got to look at multiple modes, graphing, algebraic stuff. Very important, But we'll do algebra then graph later. Let's look at 5. How do you interpret each express the distance between 2 points on a number line? So that just would mean that A and B, I guess that's what they want to think about. A and B are real numbers. A and B are 3 away. And same thing, I'm just going to use double quotations as repeating. If you have absolute -3, same thing, they're 3 away. Just happens to be one's maybe on the other side or something like that. This means that A and B are the same. So I guess what is going on here is that A and B are real numbers and distance between the points A and B on a number line. So for example, if I have like 2 and 5, the distance between them can be expressed as absolute 3 or absolute. But if they're the same number, like say I have like 2 and 2, then of course, the absolute value 0 would describe the distance between those 2 points. So just a short discussion about that. 6. Yeah, so basically I kind of had that discussion earlier with number 1 part D. Y minus m equals 10. So y minus m is 10 away from 0. So this is going to mean that x minus 2 is 5 away from 0. Or we could think of it as actually, before I do that, let's actually work it out first. Remember, it also says those negative counterparts. So what this tells us is that -3 and 7 are each 5 away from 2 on the number line. Notice how we see the 5 and the 5. So this is interpretation. That's what we're being asked to do, right? We see a 2, and we see a 2 there. So really what this kind of tells us is that we have absolute x minus a equals, let's say m or something like that. Just totally just make it, or maybe I'll use the letter n. What this really means is that there will be 2 values of x that are n units from A on a number line. That's all it's really telling us. But remember, n has to be greater than or equal to 0. Cannot be negative. So that's really what is happening here. Now, of course, if actually specific n is greater than 0, because if n equals 0, then x just equals a, and that's it. And you only have one answer. Like, for example, if you have absolute x minus 5 equals 0, x just equals 5, that's it. There's nothing else that happens. So now we're going to get to inequalities. So how do we want to approach these? You're first going to do that, and then you're going to do this. The reason why is that, of course, x is more than 6. But that's not the whole story. There's more that can happen. What else could happen is that x is less than -6. Actually, we're going to say less, greater than, less than or equal to. If you graph on a number line, here's 0, here's 6. We fill in 6, we go further in that direction. Oh, great. Let's use a highlighter. So we go in that direction, and of course, -6, we fill it in, and we go in that direction. Notice this is the OR inequality. Greater or, kind of rhymes actually. So there's no overlap, but these are the values of x that would satisfy the absolute value inequality. And the technique again is solve it like it looks without the absolute value. Of course, is x is more than 6, but x could be less than -6 because you put -7 or -8 or -9 or -10. Those are all less than -6. That would still satisfy the absolute value inequality, because then the negatives would become positives, like 7, 8, 9, -7, -8, -9, -10 would become 7, 8, 9, 10, and of course those are more than 6. So, and you'd write it as an OR inequality. Let me jump down to part D. So x, of course, is smaller than 6. And of course, x is more than -6. You have to be careful, because if you just say this, then you're saying that like -10 would work. But of course it would not, because that's why -10 is 10. 10 is not less than 6. So you have to be a bit careful here. When you get the less than, it's going to be the and situation. Less than, and, not sure if that kind of rhymes. But there's going to be an overlap here. So it's going to be an and situation, which you can actually show like this. So again, here's 0, here's 6, here's -6. You're going to shade in between. So it's an overlap. And it's not going to be or, because if you do say or, then you're implying that, okay, as long as I'm less than 6, anything less than 6 would work. Or as long as I'm greater than -6, anything. But then the answer would be all real numbers, and that wouldn't make any sense. Um, so that's why the answer is going to be just that. So there are a few more here. So what I'm going to ask that you guys do is I'll set them up, and I'll ask that you kind of just do these on your own at home, and we'll discuss it in class. I'm not asking the answers for these in the Google form, and I'll just kind of come around and just look to see that you attempted these. If you get stuck, that's fine. You can always come during office hours, or we can talk about it in class. But you're going to solve each of these individually, and then see what you get. Just so you know, this is going to be the OR case, and C is also going to be the OR case because you have the greater. So you kind of know before even solving. That's going to be one of the other questions in the Google form. Is that if you see OR, if you see greater, it's going to be the OR case. And here, those are each going to be the less case. So 2x minus 7 is less than 1. 2x minus 7 is greater than -1. So you're going to expect it to be in between two numbers. However, we already know this is no solution. Why? We'll talk about that next time we meet. But just kind of think about it. So you don't need to necessarily break it down, but think about why that would be no solution. Remember, it's -24. Kind of a big hint. Okay, that ends the video.